Process engineering is where reality and theory kind of come together. For example, I was working on a job out in Oklahoma on a sour water stripper. The feed to the sour water stripper contained light hydrocarbons. The objective of the stripper was to get the light hydrocarbons out. I was able to gauge the amount of light hydrocarbons that were left unstripped in the bottom of the tower by getting the sample in a graduated cylinder. Waited 20 minutes for the hydrocarbons to settle out at the top of the cylinder. In this way, I was able to gauge the stripper efficiency. Initially, the feed rate to the stripper was about 60 gallons per minute. And I wanted to increase the feed rate to 120 gallons per minute because that was my new design spec. The question was, as I increased the feed rate by a factor of 2, I was going to increase the reboiler duty, the stripping steam, also by a factor of 2. How would this affect stripping efficiency? I guess if you were running a computer simulation, you would have assumed constant tray efficiency and expect that if the reboiler or steam rate doubled and you doubled the feed rate, it wouldn't have made any difference. But much to my surprise, when I doubled both the feed rate and the stripping steam rate, the amount of naphtha I accumulated in my cell graduated cylinder vastly diminished, meaning stripping efficiency greatly doubled as I increased the vapor liquid load on the tray. Why was this? Well, it was that way because these sorts of trays, valve trays or grid trays or sieve trays, are not like the old ancient bubble cap trays. They have a tendency to leak or weep or dump at low vapor rates. If the tray was actually level, that wouldn't matter. But nowadays, guys, trays are not installed especially level. And in this case, the trays must have been badly out of level because doubling the vapor rate through the trays greatly increased the pressure drop of the vapor flowing through the tray, and that stopped the apparently out of level tray from dumping or weeping or leaking, which was undermining tray efficiency. So again, when I doubled the steam rate and doubled the feed rate, tray deck vapor liquid contacting efficiency greatly increased. Now, how does one take this into account when running a computer simulation? I mean, how do you know what the tray efficiency really should be? And the answer is, well, there really is no answer except for performance test. And that's what I like to talk about in my webinars, the importance of making direct field observations, the importance of running tests to see what the actual tray efficiency is, so it forms the basis for further calculations. Again, what we're looking at is the junction between reality and theory, and that's what process engineering is all about.